Now we are going to introduce the state of the art of the project. This state of the art is a study of another types of egocentric dataset. It was required because to construct this dataset, it had to be similar than other dataset, but with some other difference. For that, it was studied these two types of egocentric datasets. First of all, the GTEA dataset that consists in 4 videos recorded indoors, and all of them are cooking different types of meals. And the UT-Ego dataset consists in 17 videos recorded both indoor and outdoor, but consists in daily actions like driving, cooking. Here we can find the link of the 2 datasets. Now, the main part of this project is the construction of the EgoMon Gaze Video Dataset. How I said before, a calibration process of the glasses is required to accurate recording of the data. For the project was recorded and uploaded to YouTube a video with explaining this process, the calibration process. Here you can find the link of the video tutorial. This calibration process has 2 types of results: the accuracy and the tracking. It has to be the most perfect possible, because it means that the accuracy of the eye tracker is in the exact point of gaze. Here, for example, we can see in these calibration results, in these good, almost perfect calibration results, the wearer of the glasses was trying to read this sentence that we can see here, and we can see the point of gaze just in the sentence. But here we have an example of bad results of the calibration process, and the wearer of the glasses was trying to follow this light, but the point of gaze, we can see that is here. So when I were recording the data set, if the results of the calibration process were bad, we had to recalibrate again the glasses. Okay, the EgoMon Gaze Video Dataset. It consists in 5 separate things. First of all, the 7 videos recorded for this dataset. It has 7 videos that more or less 30 minutes each one of them. So from one part we have these videos clean with any type of gaze data. For other part we have these 7 videos with the point of gaze plotted on them, and for other hand we have the 7 gaze data files extracted from the glasses. From the videos was extracted frames for using one sampling, one frame, and we decided, I'm going to say why later, but we decided 1 frames per second. So it means 30,428 frames extracted images. And then by the other hand, for one of the videos was used as well the other device, narrative clips, so we have 75 narrative images. The recording of the data, of the dataset, was carried on using 3 different participants of the project. One of them is me, the author of this project, and the others were students in the Dublin City University. There are presented the 7 videos that form this dataset, the EgoMon dataset, but it was recorded 9 videos, but at the final we discarded 2 of them. We have 3 videos indoor and 4 videos outdoor, but it was discarded one video indoor, it was because the video was very similar than another already recorded, so we decided to delete it. And the other because we had a problem with the gaze data, so we decided to record the same video again. The first of the videos is our representation. It is during a presentation of two different projects. In the first part, the wearer of the glasses was presenting her project, and in the other side was looking the person that was presenting his project. The second video is during a park. The wearer of the glasses was walking and seeing all the views of the park. And for example, we can see examples of the wearer of the glasses one of the friends of the wearer of the glasses pointing a map, or for example, the wearer of the glasses walking and appears a person, and then the point of gaze going directly to this person or to a dog, for example. The third video is the wearer of the glasses was cooking a Spanish omelette. So we can see all the static actions, how the person is or frying these potatoes. The other is playing cards. It was recorded during a game cards play, and we can see the wearer of the glasses looking the cards, looking the game, and looking the friends. The other video is in botanic gardens of Dublin. We can see here the wearer of the glasses walking around all the gardens, and for example, in one moment of the video we can see how the wearer of the glasses was following a squirrel in a tree, and we can see the point of gaze just in the squirrel. This video was recorded with the other tool used for this project, the narrative clip. In this case, we said that narrative clip can be put in the clothes, but we decided to put here in the front, because the images taken for the narrative had to be very similar in the same level that the images taken from the glasses. We can see that the two cameras are very close. Here we can see an example of one of the images taken from the narrative clip. Another video is a bus ride. It was recorded. The wearer of the glasses was seated in a top of a bus, but the scene that he is recording is in movement. So he's static, but the scene is moving, and is in all the streets of Dublin. And the last one of the videos is the walking to the office. We can see the wearer of the glasses going to an apartment until the office in the university, walking around the streets. How we want to publish this dataset, we had to take into account the European Data Protection Directive. This directive says that there cannot appear persons that hasn't give their authorization to appear in the videos. So a post-process of the videos was necessary to blur faces. Okay, how all these videos were recording in different types of environments and movements, it means that maybe in some parts of the videos can exist some losses with the gaze data. Here we can see the percentage of the losses in each one of these videos. First of all, we divided the videos in outdoor and indoor environments, but here we can see that the non-static videos can have more losses than the other. It is because in the non-static videos, like for example, walking to the office, exist a lot of heavy movements of the head, or can exist that the person of the wearer can see a very open view, and maybe the point of gaze can be lost. And by the other hand, the static videos, like for example, cooking the Spanish omelette, the wearer of the glasses were looking all the time in the same point, so it's more difficult to have losses. Okay, the processing, the extraction of the data of this dataset was carried on with the Tobii software tool, and it consists in 7 files of 7 gaze data files. The frame extraction of these videos, we extracted frames from these videos. We had to decide a sampling of how many frames per second, and we decided that use the state-of-the-art saliency, the same number of images that the state-of-the-art saliency prediction used to train their convolutional neural network. So we decided for 1 frame per second that has more or less 15,000 of images. We can see here the average of duration of all the videos is more or less 34 minutes and 2,000 frames for each video. Okay, the state-of-the-art saliency prediction that was worked in this and tried to evaluate his validation in this project is SalNet. We are going to explain it later, but first of all, it's necessary to explain what is a visual saliency predictor. A visual saliency predictor tries to predict the visual human attention. That means that, for example, in this image, we can see here a tower and a house and the beach, but the most important point of the visual attention human is the tower, for example, and the house. The state-of-the-art saliency estimator used for this project is SalNet. This SalNet was coded using the library CAF and the language Python, and here, for example, we have one of the results of running this convolutional neural network. This is the Lena image, and this is the predicted saliency map. How we explained before, the dataset consists in 5 different things, but also has the same number of saliency models for each frame extracted. So the same number of images. The results of the dataset, well, the dataset can be divided in 3 parts. The clean video, the video with the gaze data or the fixations points, and the saliency maps. So to try to evaluate the validation of SalNet, it was required a comparison metric of these 2 results, the fixation points and the images with the saliency models. Basing on a paper, we can see that there is two important groups for a comparison metric: the location-based metrics and the distribution-based. The location-based are they compare fixation points with an image of a saliency map. So we used one of them, but we decided to use this NNS, normalized scan path saliency, because the SalNet was presented in a benchmark in MIT, and he got the best result in this metric. So we decided to use this metric. Here we have the explanation of the metric that compare the location of the fixations with the 2D image of the saliency model. Here we can find the link of the results of the MIT benchmark. Okay, that are the results of the comparison metric with each one of the videos that form this dataset. Here we can see the average of these results, and this is the result that Salnet obtained in the MIT benchmark. We can see that the average it's significantly lower than the result obtained in the MIT. But we can find that some of the videos has a result very similar than the MIT results. But we can see that most of that videos that has the best results are in non-static environments and indoor environments. For example, the presentation and the Spanish omelette. That means that these videos were recorded in an static situations. So all the person that was wearing the glasses were looking most of the parts, so most of the important saliency parts of the video. And this is a qualitative evaluation of these results. For example, this is an example of a good results. In one of the static videos, the Spanish omelette video, here we can see the wearer of the glasses frying some potatoes and looking just in the potatoes. And the most important saliency part for Salnet are these potatoes. And here, for example, we can see the wearer of the glasses looking all the ingredients, and for the saliency map, the ingredients are the most important part. But here we can see an example of a bad results of the comparison metric. For example, in this specific case, the wearer of the glasses was cutting potatoes, so his point of gaze was fixing the knife that cutting these potatoes. But for the saliency model, the potatoes and the hand and all this part of here is the most important. So we can see that the results are not similar. And here, in this specific case, in this specific moment, the wearer of the glasses was fixing his gaze in this tree. But for the saliency model, the most important is the person that appears in this frame. Okay, the conclusions that we can extract from this project are two. One of them is that the EgoMon Dataset was constructed, and it has very significant difference between other types of egocentric datasets. One of these differences is that it has a lot of different types of environments, very different videos, both of them indoor and outdoor. It has daily actions and, for example, tourist actions. And the other difference is that, for example, this dataset has a lot of data. It has two types of videos, with clean videos with the gaze plotted on them. It has the saliency models for each one of the frames extracted, and these saliency models can be used for another types of studies in the field of computer vision, how image recognition. And the other conclusion that we can extract from this project, is that the evaluation of the validation of the saliency model was studied, and we can conclude that the results in average were more or less bad, but this is because the saliency estimator was trained with non-egocentric images, and this dataset is formed with egocentric images. So that offers an open window for future works of this project. And the most important is a fine-tuning of the saliency estimator based on egocentric images and based on this comparison metric, the NSS metric. Finally, a publication of a web page explaining the dataset, the EgoMon dataset, is published, and here we can find the link of this dataset. And that's all. Thank you for your attention.